It's a genuine pleasure to welcome our speaker tonight, Dr. Paul Donald. His parents tell the story that when Paul was about 10, his parents took him and his sister down to Dorset for a holiday, and they set out one day from a lovely countryside setting to walk to Thomas Hardy's birthplace. Paul decided instantly that this wasn't a walk for any self-respecting 10-year-old and asked to be left where he was. 2 hours later, his parents returned to find Paul in ecstasy. He discovered birds and bird watching and listening to birdsong in that 2 hours. "Why didn't you tell me about this before?" he said. And this point of conversion led to Paul's lifelong interest and to his career as a bird scientist with RSPB, the British Trust for Ornithology, and BirdLife International, and to the writing of a number of books, the latest of which he's going to tell us about today. So without further ado, a very warm welcome from Buxton Field Club.
Well, thank you for that lovely introduction, Peter. Would it be better to, oh yes, thank you. Right, can everyone see that okay? It's a real pleasure to be here. One thing that Peter didn't mention in his introduction is that I was actually born in Buxton, not very far from here. But the fact that I didn't grow up in Buxton, I grew up in Manchester, is actually part of the origin of the talk I'm going to give tonight. I was born in 1963, which some of you may know was the year of the Beeching Report, the report that led to the decimation of Britain's railways. And my parents, who are here tonight, have never driven. They don't like cars, they never have done, they've never learned to drive. And because my father lived in Manchester at the time, they had to move because they thought that the Buxton to Manchester rail line was going to close. It didn't, in fact, but they moved. And so I grew up in Manchester. So I don't have the sort of moral compass of my parents. And as soon as I was old enough, I started driving largely so I could go twitching rare birds around the country. But I've always had this kind of residual sense of guilt growing up. And I think that's kind of means I've kept a very close eye on the scientific literature around the impacts of motor vehicles on the environment. And this is kind of what's led us to today. So Buxton's kind of part of the origin story of this work. So the kind of subtitle here is how the car wiped out our wildlife. And the reason I went down this road is because I became increasingly convinced, having followed the development of the scientific literature over the last 20 or 30 years, that conservationists are missing something. They're missing a big part of the picture. And the sort of subtitle to this is "and nobody noticed," because I think that really this is the elephant in the conservation room that nobody is seeing. So I grew up, I was born in Buxton, I grew up in Manchester, I lived in various places down in the southeast of England for a while, but 3 years ago, my wife and I moved up to Galloway in southwest Scotland. And we lived not far from the historic little town of Whithorn. And like many Scottish towns in that area, Whithorn is essentially just one long street with houses down each side. And if you stand at the top of the main street, it's a Georgian street, it's actually called George Street. If you stand at the top looking down, you get a very fine view down this very wide street, and there are hills in the background. You can't quite see them in this picture. And this is a view that's been photographed many times over the years. And the local history Facebook group are always posting photographs taken from this same spot looking down this road. So you can put them together over time and see how things have changed. I think this is maybe about 1890, I would think, looking at the, it's not dated, I'm going to guess about 1890. I always like to think that this guy here is a doctor. He looks a bit sort of doctorly, and he's got a sort of doctory bag. And you can see, looking down the street there, fine view, houses all the way down. And if we flip forward again, I'm going to put this at about 1920. There's a war memorial appeared here, so it must post date 1918. So I'm going to guess from the style of the clothes about 1920. And what's changed? Well, electricity. Whithorn now has electricity. Electricity pylons have appeared, but the buildings are all exactly the same. The doctor from 40 years, 30 years earlier could walk down there and probably not notice much difference. I'm going to put this one at about 1960, something like that. The same power lines are here, but now we've got some street lights, and television aerials have appeared down here. But everything else is pretty much the same. The houses are all the same. You could walk down there and you wouldn't know which year you were in. The houses are all exactly the same. The fabric of the town hasn't changed at all. And this one I can date very accurately because I took it earlier this year myself, 2025. The power lines have been put under grounds and they've been replaced with these rather nice street lights. Bizarrely, the television areas have gone, streaming, so forth. Interesting, isn't it? But again, the fabric of the town, the buildings haven't changed at all. That doctor of the 1890s could walk down here and see not very much change to the fabric of town, except for one thing, of course. 1890, there were no cars. 1920, I can count 6 cars in this picture. 1960, I can count about 20 cars in this picture. And I got to about 52 cars in this most recent picture, but that's an underestimate because there are some kind of hiding behind others. And really, this has been the most fundamental change that's taken place in Whithorn and in many places across the country. This is one of the biggest societal changes of the last century, the arrival of the motor car. And I'm going to argue also one of the biggest environmental changes of the last century. But there's something a bit odd, which I can't really explain, which is that this phenomenon has no name. We don't have a term of reference in our English language to describe what has happened here. And I realized very early on that I couldn't write this book without having such a term, so I had to invent one. And that term is traffication. And I'd be really interested to know if anyone's got any ideas why this utterly fundamental societal change of the last century lacks a common term of reference in the English language. I think it's very interesting. And maybe I'll come on later to suggest a reason why. But I think traffication isn't just one thing. Traffication has a number of dimensions, and I think that 3 of them are really important as far as wildlife is concerned. Firstly, the increase in the distance driven. So that's a function of the number of cars that there are and the amount of driving that each car does. Second is an increase in the speed of those vehicles. And the third is an increase in the pervasiveness, the extent to which the countryside is affected by those vehicles. So you can imagine that there could be a huge increase in the number of vehicles and speed, but if vast tracts of the country are left undisturbed, then that would be less of a problem. So these are the 3 kind of elements of traffication. And I think each of them has its own sort of separate impact. Each of them forms an important part of the story. This is, just out of interest, this is Britain's first motorist. This is the Honourable Evelyn Ellis in his car. It's a French car, a Panhard Levasseur. Pretty much all the cars in the world at that time were being made in Paris. And he imported it 1895. He imported it and made the first car journey through the UK. And amazingly, this car still survives. You can see it's in the Science Museum in London. And then a kind of interesting foretaste to the environmental devastation it was to bring. The rain hood, which you can see here, is made of elephant skin. So let's have a look at some of these 3 different dimensions of traffication. So the first one is how much driving we do. And this graph, it's actually, can you see that? It's the year from 1950 to 2024 across the bottom. And the graph shows the amount of vehicle miles that we drive in Britain. So vehicle miles is a function of the number of vehicles that there are and the amount that they all drive. And we do now an astonishing 350 billion vehicle miles in Britain every year. That's a trip to the sun and back every 4 hours. That's just British drivers. Quite astonishing. And the important thing is that this is a real zero down here. So the graph is absolutely proportional. And if you take, well, 1963, I mentioned already, the Beeching Report, Year of My Birth, Beatles' first LP, we did less than a quarter of the driving that we do today. And even what to my mind is a relatively recent thing, like the first space shuttle flights, the arrival of the mobile phone in the 1980s, we did less than half the driving that we do today. And you'll see that this pattern of increased driving has increased, with one obvious massive exception, and that was, of course, the 2020 COVID lockdown year. I'm sure many of you remember that summer of quiet where the traffic stopped. But the interesting thing was, even though that seemed like a really unusual year to us, that was kind of normal traffic levels in the mid-1990s. That's how much things have changed. And I think that maybe the reason that we don't have a word for this phenomenon is that it's crept up on us. It's about a 1% increase per year. Maybe we just don't notice that kind of gradual change, and we never felt the need to coin a word to describe this process. And if you look across the amount of driving that we do across the world, the amount of driving we do is absolutely astronomical. If you took Britain's cars, just the cars and just British cars, put them end to end, it would go round the entire length of the Earth's equator, the wet bits as well as the dry bits, 3.5 times. If you put all the world's motor vehicles end to end, they would stretch from the Earth to the moon 14 times. 14 times. I've estimated that the total number of vehicle miles driven every year is about 3.5 light years. 3.5 light years. A light year is the distance that light travels in 1 year, and light travels at 180,000 miles per second. Halley's Comet has this massive deep space orbit, comes round to us about once every 75 to 80 years. In our cars and vans and motorbikes, we lap that 6 times every single day. So the amount of driving we do is quite literally astronomical. And not only are we driving more, we're driving faster. So the second dimension of traffication is speed. This is the world's first motor car. This is Carl Benz's patent Motorwagen from 1880, I think, 1879, 1880. And the cars behind it are the 1930s MG racing cars. This had a top speed of 3 miles an hour, and these had a top speed of 300 miles an hour. Of course, they're built for racing. But the overall pattern has been one of massive increase in speed. This is the National Motor Museum just outside Coventry, which is fascinating because it's an enormous collection of cars. And each car's got a very nice informative label on it saying what year it was made, how much it cost, and what its top speed was. So I spent an afternoon just writing down the year of production and the top speed. I just wanted to see what the pattern was. And this sort of little bit of impromptu research showed that very obviously top speeds have increased over time. But the interesting thing to note is that they've increased even though the maximum speed in this country is 70 miles an hour. You have to go right the way back to the 1950s to find any car in my sample that couldn't break today's national speed limit. These aren't racing cars or anything. These are sort of run-of-the-mill cars, typical of what will be, on the roads. Now, of course, people don't often drive cars as fast as they possibly can at their maximum speed, but having that power under the pedal encourages people to drive faster when they can and to break speed limits. And we know that they do. There's plenty of data to show that speed limits are regularly exceeded. So we drive faster. And the third dimension of traffication is this issue of pervasiveness, how far the effects of traffic seep into the country. And it doesn't show up terribly well on here, I'm afraid, but this is a map showing all the parts of Britain that fall within 100 metres of a road. And I've done a sort of zoomed in bit here, which actually, I think actually includes Buxton, I just realised. This bit of central England. So you can see, so this is how much of the land in Britain falls within 100 metres of a road, each side of a road. If you made each road a band 100 metres on each side, that's how much of the country would be covered. If we increase it to 500 metres, that's how much of our country is covered. That's how much of our country falls within 500 metres of a road. 1 kilometre, 2 kilometres. So you can see that most of England, almost all the land in England, most of Wales, apart from the mountains, and all the lowland bits of Scotland fall within less than 2 kilometres of a road. And in fact, this graph underestimates that, because I had to leave out about 100,000 miles of minor tracks and things because my computer wouldn't cope with the mapping. So we've had these increases in the amount of driving we do, the speed that we drive, and the extent of the country which is affected by our driving. The science of road ecology is a fairly recent one. It's only gained kind of recognition as a science in about the year 2000, but it begins here. This is a photograph taken in 1918, and this is the Iowa University expedition to Barbados and Antigua. And the eminence grise up here in the corner is Charles Cleveland Nutting. If any of you have been bird watching in Central America, you may have heard of Nutting's flycatcher. Well, that's the nutting of Nutting's flycatcher. But the two people I'm interested in here are these two. This is Dayton Stoner, a zoology professor at the University of Iowa. And this is his wife, Lillian, who became the state ornithologist of New York later in life. And apparently on the expedition, Dayton kept the expedition entertained by playing his mandolin, but for some reason, the natives of Barbados and Antigua thought he was a German spy. This was 1918, remember, and they tried to kill him. But anyway, he survived. And in 1924, it was a shame that they're sort of pictured one in front of the other, because what they're famous for is what they did when they were sitting side by side. In 1924, they went for a very ordinary journey across Iowa, rural Iowa, utterly unremarkable journey, except for one thing. Instead of just driving by the roadkill that they saw, they decided to count it along the way. And if there was a mangled mess, they would stop and get out and see if they could identify it. And they published their results the next year in a scientific journal. And that was kind of the start of road ecology. And that sort of sparked a huge increase, in a huge rise in number of similar papers. Really nice way to get a paper out. If you're doing a journey anyway, you just kind of count the birds, the dead birds and the dead mammals that you see and write an article. That's a nice, easy publication. But the roadkill has been kind of it still dominates the science of road ecology. I would say that, the majority of scientific research that's done about the impacts of road traffic on biodiversity now concerns roadkill. And one of the sort of central truths about roadkill is that it's not a random event. If you know how often an animal crosses a road and you know what the probability of it being hit is, you can calculate what its probability is of ending up like this. And a road ecologist will be able to say, yeah, this is a typical high-risk road. It's not a busy road, but it's a straight road, cars go fast, and you'll see on each side there are quite tall hedges and things. So an animal wanting to cross the road, getting on somewhere, might have to run quite a long way down the road before it can find somewhere else on the other side to get out of the road. So this is a kind of high-risk road, probably actually a higher risk road than a motorway, because most animals wouldn't even start to cross a motorway in the first place. You actually see more dead animals on this kind of road. So the science of road ecology has kind of started to shine a light on this non-random event. And the British Trust for Ornithology, in its first and unfortunately last foray into the field of road ecology, undertook a national survey in 1960, the Road Death Survey. And they found quite an interesting pattern. So this is the months of the year here, January to December, and they found that there's a real strong summer peak of roadkill in birds. And this wasn't just because they were going out more in nice weather. They kind of stratified it properly. Each person was given a bit of road. You've got to count it once a month. You've got to check it once a month and so on. So it's a fairly sophisticated survey. And they put this down to the fact that there'd be a lot of young birds around in the summer, naive birds, maybe birds trying to feed on the road or whatever. So you find all these patterns in roadkill. But actually estimating how big a problem roadkill is a very difficult thing, because a lot of the animals that get hit are kind of obliterated immediately. So if you're doing a transect along a road, you will miss a lot of what's being killed. A lot of animals are injured and flutter or wander off to die somewhere else. A lot of animals, of course, get plastered onto the front of the vehicle that hit them and so on. So, and another big problem for roadkill researchers is that predators are very good at sort of hanging around roads. I'm sure you've all seen crows on dead foxes and things, and they take the corpses away before they can be counted. So estimating how many animals are killed on roads is kind of not much more than educated guesswork. But here are some estimates. There's an published estimate from the USA for birds, 89 to 340 million birds per year killed by roadkill every year. Canada, they've estimated 14 million. Europe, 200 million birds, of which the UK contributes 30 million birds. Then larger mammals, Europe, 30 million perhaps. These are really no more than sort of back of the envelope guesswork type estimates. When it comes to things like reptiles, amphibians, reptiles, we don't really have much of a clue. Insects, you know, there was one survey from Japan that suggested 50 billion insects are killed by cars every year. One study from the Netherlands suggested it's over 1 trillion insects killed. But of course, you know, how many dead insects do you find on the road? They're just sort of, they evaporate, they're obliterated. So we really don't know what the scale of the problem is, despite all this research, despite the fact that roadkill remains the kind of most widely studied bit of road ecology. We still don't really know how much of a problem it is. But I think there is one pattern that's becoming clear, which is that for most species, it's not necessarily a big conservation problem. Those numbers sound horrendous, but to be killed in large numbers on roads, you have to be fairly tolerant of roads. In other words, you have to cross them a lot. And to be killed in large numbers, you have to be able to survive in large numbers around roads. Now, I think some species, like the barn owl, maybe the hedgehog as well, their poor conservation status might well actually be directly linked to roadkill. But the majority of roadkill animals, the foxes, the badgers, rats, crows, and so forth, common species, often increasing. And I think for those, for most species, roadkill is actually more of an animal welfare issue than it is a conservation issue. That doesn't demean it in any sense, it just puts it in a slightly different context. And what's emerging now in the science of road ecology is that the species that suffer the most from the impacts of our driving are those that never cross roads at all and therefore never appear in lists of roadkill animals. Now, for many species, roads form impenetrable barriers. And this is a road in Canada. You can imagine that very few animals, even mammals, even birds, will be very reluctant to cross this. It's essentially an impenetrable barrier. But even small roads, even minor roads, can form impenetrable barriers. And because of our incredibly dense network of roads, what that means is that we've essentially cookie cut our landscape into tiny little fragments. There's some lovely research done in the Netherlands on this lovely animal, the cop snail. And it must have been the most dull bit of ecological fieldwork ever carried out. They followed these snails for weeks and weeks and weeks and weeks. They must have marked them or something. And what they found was that as soon as these snails get to even a track, they turn back. They will not cross open space at all. So what that means is when they get to the edge of their little tarmac enclosed island, all the resources on the other side of those few meters of tarmac are lost to them forever. Mates, food, refuges from floods, refuges from frost and so forth. And one of the fundamental paradigms of conservation is that if you fragment populations like this into thousands, maybe millions of tiny little pieces, as we've done with roads, then their extinction risk shoots up massively. And this is going to be particularly a problem when animals are trying to adapt to climate change, because we know that one of the main mechanisms by which animals try to adapt to climate change is by moving to follow their shifting climate envelopes. And of course, what we've done is we've put all these barriers in their way. We've essentially just built fences, walls around these little populations and trapped them. And many of them will die out because they won't be able to adapt to climate change. But there are some species, some very unwelcome species, that can use roads to their advantage. This is a cane toad. Cane toads were introduced into northern Australia to control crops, pests of sugarcane crops. But once they got there, they decided they didn't really like eating the pests of sugarcane crops, but that the local wildlife was really delicious. And so they've proliferated. They're a huge problem. And the reason that they've done so well is that they use roads. They spread along roads. Now, because they've got poisonous sacs on the back, they're quite happy to be out in the open. They know that predators aren't going to take them because they're deadly poisonous. So they hop along roads. They're also very good at coping with dehydration. And they're spreading like crazy across Australia. They're still spreading north, west and south from northeastern Australia, causing terrible environmental problems. And they're dispersing along roads. Now, of course, we don't have this problem here, but there's also a lot of research showing that the seeds of invasive plant species are very good at spreading along roads. And there's been cases of these species being kind of taken into whole new areas, either stuck to cars or being blown along on the hard shoulder. And if that wasn't a bad enough problem, perhaps one of the biggest problems, only really coming to light now, is the effect of noise. This is a lovely report published about 10 years ago called Quiet Areas in Europe. And what it shows is the red areas are noisy, and only the blue areas, the sort of deep blue areas, are naturally quiet areas. And you can see the deep blue areas now really only in Iceland and sort of coastal Norway, and in the Alps, maybe in the Highlands of Scotland. Everywhere else is kind of yellows, oranges and reds of noise. And if we zoom into this map, this is France. What you can see essentially is that a map of France's noise is a map of France's roads. Roads are the dominant source of noise pollution in most countries. And noise is more than noise. Every week I'm seeing new papers being published showing that noise pollution has enormously bad impacts on human health. There are studies showing that people who live exposed to road noise suffer higher rates of cancer, stroke, heart attacks, hypertension, depression, a whole range of physical, terrible life-shortening illnesses. There's a load of new studies now showing that there's a very strong correlation between road noise and all forms of dementia. And this has nothing to do with what it does to your ears. This is because the body senses, your mind rather, senses road noise as a threat, and it triggers a stress response. It squirts stress hormones into your bloodstream, raises blood pressure, causes all sorts of other problems, even while you're asleep, even without waking you up. Road noise is quietly killing you. And estimates suggest that maybe 10 to 20,000 people a year in Europe are being killed by road traffic noise. And it's exactly the same with animals as well. There's not quite so much research, inevitably, as there are for humans. But there's a lovely piece of research from France, and in fact, it's been replicated in other places, which shows that blue tips and the house sparrows, of course, nesting near roads, what they did was they looked at the chromosomes of chicks in nests of these species near roads. Now, chromosomes of birds, like human chromosomes, have at their tips these little caps called telomeres. They're a bit like the kind of things on your shoelaces, and they serve the same purpose. They're to stop the DNA strands from fraying when cells divide. And what happens as you get older, your cells divide, your telomeres get shorter, and the incidence of all sorts of cancers and so forth starts to increase. It's well known that the length of your telomeres when you're young is a good predictor of how long you're going to live. And what they found was that house sparrows and great tit nestlings nesting near roads had significantly shorter telomeres than those nesting elsewhere. These birds' lifespans are being curtailed by road traffic noise even before they've left the nest. And the response of many birds is simply to abandon areas near roads, as we shall see. So if we want to try and estimate what the impact of roads is, we can take a simulation. So what I've done here is we've got three roads here: a very busy road, which is the top line, a less busy road, and a quite quiet road. And this is the distance from the road. And this graph shows how much noise they produce. Obviously, as you move away from a road, the amount of noise goes down. Now, if we know what level of noise birds and mammals start to suffer at, we can use this to work out how far away the roads are going to impact them. And there's evidence to suggest that for the more sensitive species, some of the more sensitive birds, for example, cuckoos, for example, they start to move away from areas where there's more than 45 decibels of noise. And you can see that the two busy roads here are producing more than 45 decibels of noise 2 kilometres away. 2 kilometres. So these roads are impacting. And this is assuming that there's no other road in the area. Of course, there'll be more roads producing noise. So what's happening now is that people are becoming increasingly convinced that road traffic noise is a major threat to wildlife. Less sensitive species start to react badly to about 55 decibels, but even then, with those more resilient species, the busy road is still causing problems for them even a kilometre away. So this is the start of the realisation that roads are not just narrow bands of collision risk for the odd badger and fox. They form wide bands of environmental destruction that seep deep into the surrounding countryside. And this is the kind of key message. This is the new truth of road ecology. So if we assume that the average bird is affected by road noise for a distance of about 1 kilometre from a road, this is the amount of Britain. This is the amount of Britain that falls within that noise band. Huge area of Britain. Now, if you think of pollution from a car, you might have a mental image a bit like this, sort of black smoke. In fact, this is particulates. What you can see there are the particulates. The dangerous things are the ones you can't see. Now, post-combustion filtering in cars now is so good that actually particulate exhaust emissions are very, very low, even in diesel cars. They're really low. But what you can't see here are the gaseous emissions, and they're quite toxic things like nitrogen oxides, and particularly ozone. And we don't really know too much about how ozone impacts wildlife populations, but there's some recent research from the States that shows that even low levels of ozone from car exhausts can completely wipe out insect populations over huge areas. And if you wipe out insect populations, of course, you're wiping out everything else in the food chain. And the bad news doesn't end there, because there's increasing evidence that a more important source of pollution, it's even more important than the gaseous emissions, is the particulate emissions that come from other bits of the car, particularly tyres. And until recently, people thought that this wasn't too much of an environmental problem. But then a few years ago, people in northwest USA, around Seattle, started to see this. Huge die-offs of a fish called the coho salmon. And they noticed that this only happened after rain. So they thought, well, what's happening here is clearly the rain is washing something into the water that's very toxic to these fish. And eventually they narrowed it down, and they narrowed it down to a chemical called 6-ppdq. Now, 6-ppdq, the reason it took them so long to find it is that no one knew that 6-ppdq existed before they found it. But 6-ppd, which is what 6-ppdq becomes, is present in every tyre, pretty much every single vehicle tyre in the world. Because what 6-ppd does is protects the tyres from ozone. When ozone reacts with 6-ppd, it forms this thing called 6-ppdq, gets into the water stream, and it's lethally toxic to coho salmon and other fish. But bizarrely, it's not toxic to a whole load of different fish. Even other salmon are completely immune to 6-ppdq. And when scientists thought they found 6-ppdq, they thought, what other chemicals are there that might be formed by the reaction of 6-ppd, which is in every car tyre in the world, and ozone? And they found 38 of them. And no one knows anything about how toxic those chemicals are to any animals or even to us. Road salt, and this is a whole litany of disasters. Road salt, something like 1/5 of all the salt produced in the world ends up getting dumped on roads. And even though climates are warming, the amount of salt going on roads is increasing, because China is becoming an enthusiastic user of road salt. And salt is actually a highly persistent chemical. The problem doesn't disappear with the last dump of snow of the spring. It's a persistent chemical. There are lakes now near roads in North America that have a salinity a quarter that of seawater, with devastating impacts on all sorts of freshwater life. And it's even come to light recently that road salt contributes to global warming. What happens is that salty water enters lakes, and because it's heavier, it sinks to the bottom, and it kills off all the aerobic life at the bottom, and anaerobic life takes over, and anaerobic digestion is a huge producer of methane. So here's the irony, that stuff that we dump on the roads to combat frost is actually leading to significant contributor to climate warming. And then it doesn't end there. Light pollution. This is probably the area that we know least about, but actually could prove to be the most significant impact of all. Throughout the evolutionary history of life on Earth, only one thing has remained constant, and that's the daylight cycle. Continents have moved around, temperatures have gone up and down, the acidity of the sea has changed. But the daylight cycle, the light-dark cycle, the natural light-dark cycle, is the only thing that hasn't changed throughout the evolutionary history of all life on Earth. And as a result, many, many animals and plants use this daylight cycle as a cue in all sorts of ways in their, it's an immensely important part of their lives. There are trees in the tropics that are so sensitive that they can detect differences in light, because of course in the tropics you've got very little difference. It's kind of light and dark in the same ratio all year, but there is a little bit difference, and there are trees sensitive enough to detect that and use that to time their flowering and fruiting. And we don't really know too much about this, but we do know that this could potentially be an enormous threat. And not only are we illuminating the dark, we're illuminating it in wavelengths of light that are completely unnatural, LED lights, for example. So, whole litany of potential threats. Now, when I started my career in conservation science back in the late 80s, there was one game in town, the only game in town, and that was the intensification of agriculture. About that time, it became clear that all these farmland birds, skylarks and grey partridges and so forth, were falling off a cliff. Birds that had previously been so common that no one was concerned about them at all, suddenly found to be in steep decline. And in the 1990s, pretty much every conservation scientist in the UK was working on the issue of agricultural intensification. I spent 4 years doing nothing but looking at skylarks in intensive cereal fields in East Anglia for 4 years. And it was a huge research effort, one of the biggest research efforts in environmental science ever undertaken in Europe. And it indicated for many species, yes, there are direct links. The great insight was that each species is affected in different ways. Some species were affected by pesticides, but for other species, it was changes in the timing of planting or harvesting that were more important. But the bottom line was that, yes, agriculture is to blame. If we fix agriculture, everything will come back. And graphs like this seem to show it. Each dot on this graph is a year between 1970 and 2022. And this is cereal yield, which is a kind of measure of intensity. And this is a farmland bird indicator, the BTO farmland bird index, which kind of tracks the trends of farmland birds. And you can see that when cereal yields were low, when agriculture wasn't particularly intensive, farmland bird populations were high. And as agriculture has intensified, yields have gone up, farmland bird populations are low. And this seemed to sort of confirm what we knew. This was like further evidence, yes, the intensification of farmland is the main cause of loss of biodiversity in our countryside. The case is closed, but we missed something. We absolutely missed something. Now take a look at this. This is the same graph, but this time I've put traffic volume along here in billions of vehicles miles. And the correlation, in fact, is even stronger. So what we've seen is that as traffic volume has increased, so farmland bird populations decline. Now, the more statistically minded of you will be thinking, but that's just a correlation. That doesn't mean anything. And you're right. If I want to try and convince you that the growth of road traffic has had a direct impact on Britain's wildlife populations, I need to do a little bit more than just show this graph. And you might be thinking, is it even vaguely plausible that roads, which cover less than 1% of Britain's land surface area, could have anything like as big an impact as intensive agriculture, which covers 70%. You can't even see the roads in this picture. You can see the intensive agriculture. My argument is that the roads that you can't see in this picture have contributed as much to the loss of biodiversity in this landscape as the intensification of the agriculture that you can see. And I'm going to try and prove that to you now. It's going to get a little bit complicated. I need a calculator, and this is my calculator. I call this the Traffication Ready Reckoner. And it's actually quite easy. So what we have here is distance from road, and what we have here is how much percentage of land is within that distance of a road. And I've got 4 lines. Let's just concentrate on the thick one, which is the whole of Britain. I've got separate lines for England, Scotland and Wales. And it works like this. What percentage of our land falls within 1 kilometre of a road? Okay, so we go up from 1 kilometre to the thick line and we read across 78%. So 78% of our land surface in Britain is less than 1 kilometre from a road. Okay, and we can do the same for England separately. Go up to the line for England, read across 92%. 92% of England's land is less than 1 kilometre from a road. Okay, so this is how you use it. And you can read it the other way as well. You could say, okay, how far from the road is 70% of our land? So you have 70% across there and you read down and it's about 700 meters. Okay, so 70% of our land lies within 700 meters of a road. Now, why did I pick 70% there? Because that's the area covered by farmland. So what this means is if roads depress wildlife populations for 700 meters on each side, then they're impacting the same amount of area across the country as intensive farmland is. Here's the most important relationship in conservation that most conservationists know nothing about. This is a really common pattern, that close to roads, animal populations are really low, and as you go away, they gradually recover and they reach stability some distance away from the road. Okay, so this is the distance away from the road at which natural populations start to occur. So the distance between the road and that is called the road effect zone. That's the distance from the road outwards over which animal populations are reduced. And if that distance is 700 meters or more, then this is impacting more of Britain's land than agriculture is. It's a bigger area. So do we have any estimates of the road effect zone? Well, we do. For UK birds, it's about 700 meters, exactly the same area as being affected by agriculture. For the Netherlands, there's a study suggesting very, very similar, remarkably similar, in fact, 650 meters. An average, a different study looked at it was a review study across things. It came up with an idea. It's actually a bit more. It's about a kilometre. Birds on average are reduced in numbers by about a kilometre either side of a road. For bats, something between 500 metres and 5 kilometres. Butterflies over 350 metres. Reptiles over 500 metres. Larger mammals, 5 kilometres. Populations of large mammals are depressed, reduced within 5 kilometres either side of a road. That's a band 10 kilometres across with the road in the middle, and numbers of mammals are reduced within that. So if we go back to our calculator, that's the 700 metres that represents the area of agriculture, and this is UK's birds, sensitive UK's birds, exactly the same. And this is the global average for birds, it's 1 kilometre, and this is my calculator only goes up to 4 kilometres, but for large mammals at 5 kilometres, because it's basically the whole country. So what this means is that we need to look at this landscape again and look at the problems that the biodiversity in this landscape is facing in a different way, because there's an invisible killer here. We can't even see roads in this picture, but the roads are having an impact on this environment that extends across this landscape to an area at least as big as that covered by agriculture. And of course, in many places, animals will be suffering, birds, mammals, plants will be suffering from both things, both agriculture intensification and roads. And we'll never know how many of the million pairs of skylarks we've lost in this country we've lost to agriculture, how many we've lost to roads, and how many we've lost to the combination of those two. But the important point is that roads are not just narrow strips of collision risk, they form enormously wide bands of environmental damage that seep deep into the surrounding countryside. And this is the key message of road ecology. So why is that? Why is it that populations of all these animals are much lower near roads and then increase as you move away from roads? Well, we've come across some of them already. Maybe it's pollutants from exhausts. It may be roadkill. It may be the ones that live near the roads are being killed off, so populations near roads are reduced. But at least for birds and mammals, it's becoming increasingly clear that actually it's noise pollution. It's noise pollution that's driving populations of animals down very large distances either side of the roads. And the most elegant demonstration of that comes from these wonderful experiments that have been done in one in North America and one in Japan. And what researchers did was they went to an area of pristine woodland miles from the nearest road, and they set up an array of microphones 1 kilometre long. And they went out there and they counted all the birds before it. And then what they did was they played the sound of moving traffic through this array of kilometres, this array of loudspeakers. Okay, so what they've done is they created what they call a phantom road. There's nothing there except the sound of traffic. And guess what? They created a road effect zone. Birds in the area disappeared up to about ½ kilometre away, and before the numbers returned to normal again. They were able to create this road effect zone just by using recordings of traffic noise. But there's another weird thing going on here as well, which is that some birds show exactly the opposite pattern. Some birds are actually much more abundant near roads than they are further away. And this is kind of weird, and no one really knows why this should be. It could well be that if they're resilient to the effects of traffic noise, then they can benefit from the fact that all the sensitive species have moved out, so there's no competition for resources, so they can live in higher densities. And this is called an inverted road effect zone. These relatively small number of resilient species are actually benefiting from roads in having much higher numbers near roads than further away. So we have one group of species that are being wiped out near roads, not even that near roads, wiped out because of road noise, and another species that are benefiting. And what this has done, I think, is to fundamentally change the entire bird community of the UK. So what this pie chart shows, imagine that this is all the birds in Britain, okay? And you can't quite see them, I'm afraid. For the 11 species that have 2 million pairs or more, the commonest species in the UK, I've mapped them out separately. So this is wren, robin, house sparrow, wood pigeon, blackbird, chaffinch, blue-tipped, dunnock, meadowpipit, coal-tip, willow warbler. And all the UK's other 240 breeding species are in that bit there. And what this shows is a massively imbalanced bird community. 1/4 of all the individual birds in the UK are of one of 3 species, wrens, robins, or house sparrows. 1/2 are of 6 species, 7 species. Now, if you took a natural, undisturbed environment, you would expect to see the species much more evenly distributed around here. And what's happened, I'm increasingly convinced, is that this is to do with roads. This is because of roads. Because if we look at how these species respond to roads, we find that 9 of those 11 species, the commonest species in Britain, occur in higher numbers near roads than further away. And their populations are increasing. Okay, so these are the road sensitive species. The 2 exceptions, meadow pipit and willow warbler, now the reason that they're common is because they occur in very high densities in upland areas or in areas away from roads. And guess what? Their populations are declining and they show a great sensitivity to road traffic. So road traffic has driven down the populations of many species across the UK, and it's fundamentally changed the bird community of the entire country, which takes a bit of getting used to, doesn't it? You probably came in here thinking that, oh, at worst, this is going to be about a few dead hedgehogs. And now you're finding out that road traffic destroys pretty much everything, pretty much everywhere. I'm going to take a break. I can promise you the second part is both shorter and much more cheerful, because in the second part, I'm going to be talking about solutions. And I can also promise you there's no more graphs. So from here on in, it's all good news and pretty pictures. And okay, right. Okay. Thanks for coming back. I didn't expect to see so many of you back after that depressing first half. But so to sort of reiterate the depressing bit before we get onto the good bit. Oh, come on, really? You know traffic's really bad, don't you? Okay. Then I succeeded in the first half. And you know, I reckon that the great majority of professional conservationists in this country, people working for conservation organisations, don't know about this. It's a real blind spot to the conservation world, which is kind of why I wrote this book, why I'm going around giving this talk. But the good thing is that there's plenty of solutions to this problem. You may think that this is a bit of an intractable problem. No one's going to give up their car for a few skylarks. But actually, I think that there are lots of solutions to this problem, and many of them are available to us immediately. You might be thinking, well, I know what this is going to say. Electric vehicles, that'll solve everything, won't it? In fact, I think, sorry, electric vehicles will make things worse. Okay, for a number of reasons. Firstly, I said in the first section that for birds and mammals at least, and possibly for a lot of other animals, road noise is the problem. And you might think, well, electric vehicles, nice and quiet. In fact, over about 30 miles an hour, electric vehicles are noisier than combustion vehicles. Most of the noise produced by a car isn't from the engine, it's the rolling noise and the aerodynamic noise. And because electric vehicles are heavier and have wider tyres, they actually create more rolling noise than combustion vehicles. And they produce more tyre wear particulates because they're heavy. But probably the biggest threat is that although there isn't a huge amount of data on this, there is some evidence that when people transition from petrol to electric, they drive more. Some figures suggest about 600 kilometres a year more, because it's cheaper and because they think that they're not causing a problem. And of course, 600 kilometres a year per car translates into billions more vehicle miles a year. So the solution is not EVs. They will make air pollution lower in cities, but they will do nothing to help wildlife in the wider countryside. So I'm afraid that's that avenue of hope is closed to us. But I identify 5 areas where I think we can be fairly optimistic that we can do something about this problem. And the first is that we are all part of this problem. And this is, I kind of quite like this. I think it first appeared in a sat-nav advert in the 90s. You're not stuck in traffic, you are traffic. And I can't think of any other environmental problem for which the blame and therefore the opportunity to remedy it is so democratically spread among us. We don't need to wait for governments to take decisions before doing something. We don't need to wait on decisions made behind the locked doors of company boardrooms. We can do this now, and all of us can do it. And I think that's really an important thing to think about. Maybe all that's stopping us from doing something about this now is that we don't know about it. And that's, I think, a relatively easy thing to fix. For example, why can't the theory part of a driving test include a module on the environmental impacts of driving? Really simple solution. There are loads of things we can do to reduce our impacts on the environment, but if people don't know about them, how can they do them? So I think there's this kind of bottom-up approach that we can all do. If we become aware of a problem, there are things, and I'll tell you what they are, that we can do to alleviate it. But there's another, my second reason for hope is the opposite. It's a top-down thing. And my second reason for hope is that our road system, our vehicles are already incredibly heavily regulated. We have speed limits, we have tests on our vehicles' emissions, and all the evidence suggests that this legislation works. So, for example, exhaust emissions, which are heavily legislated, have fallen massively over time, whereas car tyre wear emissions, which aren't legislated at all, have increased massively over time. So we know that this legislation works. The tools that we need are there already. We don't need to invent new laws. We don't need to invent a whole new system of processes like we've had to do with climate change. All the rules and regulations and laws that we need are there already. And this is particularly important because if you just remember one thing from tonight, one thing, please let it be this, that all the damage that we cause by our driving to human health, to the environment, to wildlife, increases exponentially with our speed. If we drop our speed from 40 to 30, we might be halving our impact on the environment. And the reason for that is actually sort of basic physics. An object's kinetic energy, the energy it has, increases with the square of its speed. So a relatively small drop in speed. And anyone who says to me, oh, what can I do? I'm terribly worried about this, but what can I do? Drop your speed. That is the simplest thing and the most effective thing we can do. And of course, we have speed limits already, so we can do this. And it's happening. We've seen in Wales, for example, this 20-mile-an-hour limit coming in, mostly for human health, but the environment, wildlife will benefit as well. So we have this regulation that will allow us to do the things that we need to do to tackle this problem. My third reason for hope is that there are loads of things we can do that motorists won't care about, won't even notice. And there are some really nice things appearing now. This is a towed tunnel, I think in Germany. And you can see it goes under the road. No one driving across that road will even know it's there. And what it does, it has these baffles, these metal baffles that go along the side of the road, and they funnel toads towards this underpass where they can safely hop along to the spawning pools on the other side and then disperse later. What you don't want to do is have fences all the way along, because then you're adding to the problem of fragmentation. You want them to cross, but you want them to cross safely. And there are some more dramatic examples. This is Banff National Park in Canada, and it's a really pristine area, apart from this massive road that goes right through the middle of it. This road used to be called the Meat Maker because so many animals were killed on it. And so what's happened is that they've put in all these wildlife bridges, and they're a bit like that toad thing. There are fences all along the side of the road, but they're not to stop animals crossing. They're to funnel animals towards these bridges where they can safely cross over to the other side. Now, the impetus for this actually wasn't to do with animals. It was to do with human health and safety, because they've got a lot of big animals there, moose, bears, things like that. If a car hits a moose, it's not just the moose that will get killed. So it was a kind of health and safety issue, but there's been a huge amount of work. They've put loads of hidden cameras along here, and they've tracked animals moving backwards and forwards. They've looked at the genetics of animals on each side, and they can see that the populations on each side are interbreeding freely. The big bears and things lumbering over with their bellies full of berries to drop as seeds on the other side. This road cuts a sort of massive gaping wound through this natural environment, but these bridges act as stitches. They hold the wildlife communities on each side together and help them to heal. So there's a lot of things like this that we can do that don't involve people giving up their cars and driving. My fourth reason for hope is that there is a huge amount of investment going on now in technology. And as the awareness of particularly the health benefits, not so much the wildlife benefits, the health impacts of driving become more prevalent, so manufacturers are looking more and more ways to try and reduce the impacts of cars. This is a prototype device that's designed to collect tyre wear particles as they're produced from the tyre, kind of suck them in, and keep them for safe disposal later rather than spraying them out into the environment. Tyre wear particles are basically bits of microplastic. Tyres are lumps of plastic. Tyre wear particles are microplastics. The average family car being driven at an average speed on correctly inflated tyres produces over 1 trillion microplastic particles from its tyres every kilometre. And these things here are being designed to try and reduce that problem, to suck up the microparticles so they can be disposed of safely. And then there's some amazing work being done on the States. Rather than just having a road as a load of tarmac doing nothing, why not turn it into a solar generation thing? There's a company in the States that's estimated that if its solar roads were to replace all the roads in the States, they would produce 6 times the country's energy needs, with clear benefits for the environment, not least the fact that you don't need to put road salt on them anymore. So there's all these really exciting ideas about how we can maybe go further than reducing the impacts, actually produce some benefits from our driving. And I mentioned light pollution as being a really important problem before. Why not have a smart system where the lights only turn on around the car? On quiet roads, why have lights on all the time? Just have them so that the light follows the car down the road. And this is being brought in some countries now. All sorts of smart solutions that will have a really big impact in reducing the effects of our driving on wildlife. And we can be very smart about how we implement these. Let's say if a road goes through an important nature reserve, but the real interest in that nature reserve is its breeding birds, then put in a traffic speed reduction limit during the breeding season, and then remove it in the winter. So you're reducing the impact on motorists. You can think about things smartly like that. And there's been a lot of talk recently about AI, artificial intelligence, and I see one of the things that people are thinking about, one of the great applications of AI will be driverless autonomous cars. And I think that will be a massive step forward. There are many people now thinking about transport futures that don't have, in which the car as we know it today has no place. And what these will reduce, they will reduce congestion, they will reduce journey times, and they will keep speeds down. And if they're little light things like this, they will have minimal impacts on the environment, or greatly reduced impacts on the environment. And at the same time, the science of road ecology is improving as well. We're getting to learn more about where animals die, how animals respond to traffic. There's a road ecologist here looking at how this barrier is funneling toads away from a road. So the more we learn about how animals respond to the problem of road traffic, the more we can do to try and mitigate them. And my fifth and biggest reason for hope, is that there is a growing groundswell against car traffic. Many people are saying that peak car in the UK has already happened, and that from now on, driving will start to reduce. And we've seen this in, many cities now have these low traffic neighbourhoods. These are mainly due to issues of human health and welfare, not to wildlife. But of course, if we introduce these more widely, wildlife will benefit. And I mentioned the 20-mile-an-hour speed limit. It's very interesting to listen to the sort of criticism of motorists saying, oh, 20 miles an hour, it's disgraceful, it's terrible. Actually, all the computer simulations show that if you drop your speed to 20 miles an hour, in built-up areas, journey times decrease because congestion decreases, and congestion is what adds to your journey time. So you're not losing any time by going at 20 miles an hour. And it's quite interesting looking at the history of protest against road measures. I was reading something the other day that when Belisha beacons and pedestrian crossings were introduced in the 1920s, enraged motorists were going around at night and sawing them down. So this is a new thing. People setting fire to these, knocking these 20-mile-an-hour signs down. And there's a whole load of new organisations have kind of sprung up, which have a reduction in car use either explicitly or implicitly in their purpose. A lot of things, whether it's environmentally or health-wise or sustainability, climate change, whatever, there is now this groundswell of reaction against the car, particularly in urban environments. But unfortunately, and this is kind of my real bugbear, this hasn't percolated through into our wildlife conservation organisations. You will search in vain through the strategy documents of any of our kind of main conservation organisations. You will search in vain for any mention of road traffic. It isn't yet kind of an issue, and I don't know why. I suspect maybe partly it's because they think, well, there are no solutions to this. Nobody wants to enrage the road lobby. I've already shown there's loads of things we can do to help wildlife that the road lobby wouldn't even notice. And we're all the road lobby, basically, most of us anyway. Not my parents, they've never driven. But most of us are the road lobby, and all of us consume road transported goods. So, you know, we're all kind of in this together. But I think the conservation organisations are missing a big trick here. Not only are they missing out on the opportunity to work with a whole new constituency, like all these organisations I showed in the previous slide, the whole new swathe of potential members and allies in working against this. But I also think that unless they recognise this problem, they're not going to get anywhere. If conservationists don't engage with this issue because they think they've got too many things on, there are already too many environmental problems in the world, we haven't got the capacity to take on more. My argument would be, if you do those other things without tackling road traffic, they're not going to work. You have to do this. There's no point in doing those other things unless you also deal with this, because road traffic is just as big a threat to our wildlife as any of the things that the RSPB or BugLife are working on, and arguably quite possibly bigger. So the RSPB spent years and years and years, millions of pounds, including my salary for 4 years, studying skylarks, developing smart solutions to help skylarks in intensive agriculture, and they kind of work a bit. And where they're put down, there is a small response on the part of skylark populations, but they don't go back up to what they were. And the reason is, I'm certain, that they're not dealing at the same time with the issue of road traffic. We know from research that skylarks are very acutely sensitive to road traffic noise. Even a small country lane can depress skylarks for 1 kilometre on each side. So if you're putting in smart solutions for skylarks in intensive agricultural fields next to roads, they're not going to work. And the same is true, I think, for the cuckoo. There's been a huge amount, as you probably know, cuckoo is one of our most rapidly declining birds. And there's been a huge amount of research being done on cuckoos. BTO have been fitting satellite tags to them, tracking them all over the country, all over the world, and trying to find out why cuckoo populations are declining. But cuckoo populations aren't declining across the whole of the UK. They're declining rapidly in heavily trafficated England, but in Scotland, and particularly the untrafficated parts of Scotland, they're increasing in numbers. But somewhat predictably, the people researching cuckoos haven't even considered road traffic in their calculations. I had a master's student from Cambridge, from the University of East Anglia last year doing some work on this, and she showed really, really strong correlation between where cuckoos have disappeared from and where road traffic is. And research from 20 years ago from the Netherlands showed that cuckoos are intensely sensitive to road traffic noise. They have one of the widest road effect zones of any bird species. And that research is 20 years old. And people still aren't even thinking about road traffic as being the main reason for the decline of the cuckoo. There's a load of work done in the States on another species of cuckoo, the yellow-billed cuckoo, again showing it to be incredibly sensitive to road traffic noise. They won't come within 2 kilometres of a road. And yet nobody has really thought about this as a problem. Until we recognise this truth, that roads create wide bounds of environmental destruction that seep deep into the surrounding countryside, we won't get our wildlife back. I'm going to finish there. Thank you very much indeed for listening. I hope I've cheered you up a little bit. I've tried to sort of compact an entire book into an hour's talk. I don't know how successful, but if you want a copy, I've got hardback and paperback here. Christmas is just around the corner. Nothing says Christmas like a book about roadkill. You all agree. So if you want to buy a copy, please, I'll happily take your money up here. And thanks for listening.
Oh, thank you, Paul, for that. as they talk. Questions and discussions. If you raise your hand, and then I think Roberta will bring the mic over. Sorry, is there one? No. Yeah.
Thanks, that was fascinating. The one question that sprung into my mind, when you did the pie chart of bird species that thrive relatively well, corvids didn't seem to be mentioned at all.
Well,
and yet they seem to be, to me, the birds whose numbers have rocketed, particularly near roads.
No, that's right. The only sort of species I split out were those with populations of over 2 million. I think the corvids are all just slightly under that, so they're in the sort of grey area. But you're right. I had a PhD student in Cambridge who was looking at the road effect zones for a whole lot of species, and corvids definitely have, well, not certainly carrion crows, maybe rooks had an inverse. You know, they were more common near roads. Yeah, certainly. But it is a slightly bizarre thought, isn't it, that our driving has fundamentally altered the structure of the entire bird community of the UK. It's kind of wow.
You mentioned about EVs being a benefit to wildlife.
Not being a benefit.
Well, no, it's even so. Self-drive. Sorry.
Oh yes, yeah.
The problem is for self-drive cars is they are not actually programmed to avoid. I mean, they're programmed to avoid children and humans, but not programmed to avoid wildlife.
Not yet.
So whereas a human will brake and driving along and brake and for newts in the road and move them and things like that, and toads, etc. This will not happen with self-drive ones. So where you get the human braking and avoiding it, with self-drive you won't.
Yeah.
And so in the short term, they will be disastrous, really.
That's entirely possible. I don't think there's any one single solution that will deal with the problem. You know, it may be that, you know, for things like newts, we will need to put a whole lot of other things in, like sub underpasses and things like this.
The problem with that is that research done, I'm not a herpetologist myself, that obviously toads quite often will go along the fences, whatever. The problem is the fences have to be maintained.
Yes, that's right. Yeah.
And which then causes them to cross the road. They don't maintain. Well, you get species such as newts that will go partly into the tunnel, look at it, and then they won't go through it because they don't feel comfortable going underneath the road. So where it works for toads, it doesn't always work for other species of amphibians.
That's absolutely right. And there's been a whole load of research done on this showing that different species respond in different ways, and you have to do different things. Some things will only ever go under the road, some things will only ever go over the road, and you need to kind of work out what your target species are in a particular area. But I mean, coming back to the issue of autonomous vehicles, you know, it's not impossible that at least larger animals, they will be able to set those in future and potentially take avoiding action. I mean, I would sort of try and move away from the idea that roadkill is the biggest thing that we've got to sort out. I think it's not the biggest issue. I think that, you know, noise pollution, I think that tyre wear particulate pollution are much bigger problems than roadkill for most species, not for all species, but for most species.
There's one over to the right there.
Do you have any thoughts on why this hasn't been a topic that's been taken more seriously? You know, you're talking about a study done 20 years ago.
Yeah.
Is it anything to do with the car industry having fought it off? Or
no, I don't think so. No, I suspect the car industry is ignorant of this problem as the conservationists are. I think there are maybe a few reasons. I think firstly, it's because, as I say, the increase has been so slow. It's 1% a year kind of change that we don't kind of notice. I think it's partly because conservation, partly because road science is a relatively new science, road ecology is a relatively new science, or some of this research has been out there for 20 years, but it takes time for these ideas to percolate. But I think also maybe it's because there's no word for the problem. If you haven't got a word for a problem, how can you even start to talk about it? Climate change is a word for a problem, or a phrase for a problem. Agriculture intensification, habitat loss, deforestation, they're kind of words that encapsulate a whole load of changes to the environment, but we don't have a word for this. That's why I'm kind of trying to make one. And then maybe making a word might be kind of make it a thing, you know. And I think maybe another problem is that even road ecologists tend to work in silos. So there'll be the people who work on roadkill, and they're not working on this noise, you know, traffic noise pollution or particulates or whatever. And no one's ever tried to bring all this together into one place and say, look, here's a thing. We're going to call it traffication. Here's a big problem. Do something about it. Maybe things will change. I mean, you know, if people here are thinking, well, what can I do? I've already said drop your speed. I would also say don't drive at night unless you have to, because firstly, roadkill rates are higher at night. Secondly, light pollution is a big problem. Thirdly, there are fewer cars on the roads, so you're a bigger part of the problem, as it were. But I would also say get in touch with your local RSPB office. Why aren't you doing something about this? Because that's the kind of pressure that will force the conservation organisations into recognising this as a problem and start to mobilise their resources to do something about it. Because there's loads of things we can do. If they don't want to engage because of a fear of upsetting the road lobby, that's a ridiculous reason for doing it. Because as I've just shown, there's loads of things they can do that the road lobby don't care about or even know about.
Well, one of the things that everybody's talking about, isn't it, is the development of corridors, wildlife corridors.
Yeah.
Including, say, Derbyshire Wildlife Trust, who are looking at landscape restoration and joining areas up. In effect, you're saying that that's not going to work if you've got roads around.
Well, it won't work for some species. I mean, your copse snails and things like that, it doesn't matter how nice you make it on the other side, they won't cross the road unless you put something there to allow them to go over or under, whatever it happens to be. But we do need to address this, because animals, plants are going to have to start moving a lot more than they have done in the past. Their ranges are going to have to start moving because of climate change. All these copse snails now, if they're the climate change, if they end up in the wrong climate bubble, they can't move. They're just going to die out. So the lack of connectivity, you know, we've created, I don't know how many traffic islands there are in the UK, you know, hundreds of thousands, I would think. You look at that web of roads, each enclosed little cell. A lot of the animals in there are stuck there. They can't get out. Insects, you know, spiders won't cross roads. They're stuck. So we do need to think about connectivity, definitely, but we need to think about how animals are going to actually get over these roads. And, you know, it could be that major roads that run east-west, like the A14, are much bigger problems for wildlife than roads that run north-south, like the A1. Because most animals are going to have to go north, and a horizontal road across the A14, you're kind of, anything wanting to go north is going to have to cross it. So we need to start thinking about that kind of landscape scale solution, but we need to incorporate roads into that thinking, for sure.
When we did the RSPB number plate thing, how many decades ago?
Splatometer.
Yeah, the splatometer. Should we have been concentrating on not the numbers of species going down, but the damage that cars were doing at that point in time?
Yeah, well, Steve was asking about these a few years ago. It was quite funny. The RSPB decided to try and get a handle on this. So they asked people to clean their number plates on their cars and then drive. I can't remember how long they were asked to drive for, you know, at the end of the week or whatever, check and count the number of dead insects on the number plates. So it's all these cars, you know, you get splattered insects, and so they're asking them to count them. They call it the splatometer. And bizarrely, a lot of people wrote and said, that's cruel. You shouldn't be killing insects. Well, you're killing them anyway. I think he's counting them. And in fact, that estimate of 1 trillion insects being killed in the Netherlands, yeah, that was from a splatometer type project. But there are, I mean, there's a load of, you know, again, you ask, if you wanted to ask, what can I do about it? There's a load of citizen science projects already up and running on roadkill. And, you know, I think one of the universities was thinking of kind of bringing in a kind of splatometer type approach as well. But join a citizen science project.
It's time for one more question, Peter.
Thank you. And humans
have a limited frequency spectrum of their hearing. To what extent do we misjudge things? Because many animals may have much wider range.
Yeah, that's a really good question. This is where road ecology kind of meets sensory ecology. It comes as a surprise to most people. We actually have much better hearing than birds do. For example, than most birds do. Not owls, obviously, but the average bird, we can hear things from further away. But we hear in different frequencies. You're absolutely right. One of the things I didn't actually have a chance to talk to you was about how birds change the frequencies of their songs in the presence of road traffic. What they do is they raise the frequency of their songs. They're kind of trying to climb above the road traffic noise. And there's some amazing work done in the States on a species called white-crowned sparrow, where they've been studying this effect. And this isn't just a little sort of noise that you can only detect with, if you hear them with the naked ear, they sound utterly different. The white-crowned sparrows on the San Francisco side of the Golden Gate Bridge sound utterly different to the ones on the other side. But when COVID came and lockdown came, the urban ones immediately reverted to their original song. So there's an awful lot we need to know about how animals perceive their environments and how they respond to the kind of mess that we make out there. Yeah, so sensory ecology meeting road ecology would be a lovely avenue of research if I could have my career again. There's one other thing I actually I did mention the COVID lockdown there. There was some really interesting research done. So in the States, for example, and this is an absolute really good proof of this road effect zone thing that I was talking about before and how it's mitigated by traffic noise. They have this superb bird monitoring scheme in the States called eBird. They collect millions and millions and millions of records every year. And during they did this analysis of what happened during lockdown, the COVID lockdown in 2020. And they found that quite a large number of species were suddenly found much closer to roads in that year of quiet than they had been in previous years. So immediately the traffic noise stops, birds were straight back in again. So these things are immediate. No, really interesting.
Okay, well, thank you very much indeed for that. Thank you very much. And just before I ask vote of thanks, I have just one other little thing on my list. Is that there's a break in the meetings now for Christmas, and the next one is going to be on Friday, the 10th of January, when the topic will be British reptiles. So I'd like to now ask Mark Cocker if he would give the
Mark's
Yes, I have a very small role. It's nice to think this book has strong links with Light Road, which is where I first heard about the project, Paul. But I'm bidden to give you a vote of thanks, but I'm minded first to say all of us owe you a debt. That is all of us but two. Your mum and dad, who have never been. And then I'm minded to say, why didn't you take their example as your own? The other thing I was going to say, it's a fantastic turnout, and rightly so, because it's been a really great talk, and people I noticed have come from Leek and Glossop and
Driven.
Yes, including the person giving the vote of thanks, who thought
and the person giving the talk, and the person giving the talk,
and the person giving the talk. So you are, as you say, we are the problem. I mean, that's the extraordinary thing. But you asked us earlier, you said, have you compressed your book into an hour's talk? And I can say that you have. It was a fantastic talk. It's one of the best nature talks that I've heard this year.
Thank you.
So consummately put together. We learned so much about it. I strongly urge people to read Paul's book. It is an absolutely fantastic piece of work.
Please buy at least one.
And it's not just great because the science is extraordinary. I mean, one of the things, as Paul said, he'd read every single piece of research into roads. It is brilliantly surveyed, and that came across in the talk. But it's also very elegantly written, and I'll just give you one example of this elegance. And it kind of, you heard it this evening. As extinction driving, landscape splintering, wildlife slaughtering, soundscape shattering, pollution spewing, climate changing, health wrecking, global environmental catastrophes go, traffication might actually be quite an easy one to solve. Fantastic. Thank you very much.